Welcome to What Is It About the Weather, a podcast where we explore the many ways that weather intertwines itself into our lives. I'm your host, Mark Jelanic. This week, trust and weather robots. Can they coexist? We'll see. In any case, hope you're having some good weather this week. Maybe some good weather-related insights into your life. I don't know. We've talked a lot about blue weather and pink weather lately. Very different topics, but hopefully you got something out of both of those colors. On the weather front itself, Spain had an exceptional amount of snow. It was a storm, I think again, all this naming of winter storms, I don't quite follow. Who's in charge, whatever, but Filomena, I guess, was the name for the storm that hit Spain. It dumped, if I read correctly, not quite a couple of feet, but 50 centimeters, just short of a couple feet of snow in the capital of Madrid. And I think it's been, something, maybe 40 years since they'd experienced snow levels of that amount. It's just not common, right, down in the Iberian Peninsula for them to get that much snow. Certainly not impossible to get snow, but getting it and then getting it at that magnitude, not in the norm as 40-year time span would suggest. Being, that I've been doing more bicycling this year, I saw that some of the team, because they use Spain for training as they're getting ready for the season. And with everybody's hopes of having as full of a season racing-wise this year as possible, they were out there doing some stuff and got caught in the initial flurries. I don't know that it was heavy snow. I saw still shots. I didn't see any videos, but it looked like it was a meaningful snow. I don't know that I'd want to be on the top of on a mountain when the snow starts falling and not be prepared for that. They didn't look like they had the kits on to be prepared for that. In any case, the other thing that was announced this week was the U.S. 2020 had 22 weather-related disasters that were over $1 billion each. And I think it came in just short of $100 billion in total. It's like 95 or 98. I don't remember the exact number, but something in the mid to upper 90s, but not quite $100 billion. But 20 different events. Not surprisingly, 7 of those were tropical cyclones, but there were some other things this year that people don't think about. And they mixed some non-weather stuff in there, like the fires in the western U.S. and some things that some people would call more climate, like the drought in some areas of the country. In any case, there'll be links to that. Actually, there's some links about the snow in Madrid if you want to read it. You don't, a lot of this times, I know, going to the show notes, just type in Filomena. That's with it's F-I, Filomena. And you'll probably get the same thing. And if you go in and type in 2020 $1 billion weather disasters, I put them in the show notes for your convenience, but I know you guys know how to Google. In any case, those things are out there. This week, we've been doing so it was a year ago, I was in Boston for the annual American Meteorological Society meeting. This year, we did it virtually. It's actually still going on. I've got another session after I record here in a few minutes. But I must say that my initial experience, and I'm gonna hold back on all my thoughts, but it hasn't, I don't know, it hasn't lived up to, me being kind of a tech person, I'm not opposed to these types of virtual meetings. And I've had some virtual meetings that I've done during the course of the past year. And we're fine. But this conference I've had some struggles with, and I just don't know if they were on my end, although the magnitude of the struggles and the fact that it was happening across all my devices means probably not just me, but I may just be a single voice. Maybe it's where I'm at, my connection and my provider and that sort of thing led to some struggles. In any case, the good news is with this conference is they're recording all these sessions. So I'm going to go back and try to watch some of them that have been recorded, and hopefully that they will be a better experience for me watching them in a recorded environment. But you may hear from me a little bit more on the conference as we get, weeks down the road. But this one, a big focus for me lately, one in the grant writing that I mentioned over the early part of January, and in this conference itself was very tuned into artificial intelligence. Now, this year was and I think I may have mentioned this in the past, when you get these big meetings together like the American Meteorological Society, we tend to have what are called smaller conferences, right? So you might have a conference on hydrology, if you will, or on the political side of things. I sat in on a session today that addressed that, or you might have something that's about aerosols. There's a lot of things that are of no interest to me. There are some things that, I have an occasional interest in, like I'll go to one segment, a session that may last an hour over, the course of the week. I may hit one or two individual ones of just, they'll do grouping of topics even within the larger conference. And then I'll usually have one or two conferences that I'm paying attention to. Given my background, hydrology tends to be one of those. There was one today that I didn't end up watching it live, but I'll go back and do it, that talked about, landfalling tropical cyclones. So I'll certainly go back and get those. But one in this year that I've not really spent much time in the past was artificial intelligence. The topics caught me immediately, maybe because I've been writing grant related efforts in that area. But so I thought I'd sit in on it. Now, this is the 20th time that this conference has convened. Now, that doesn't, even best case, that means the first one took place no later than 2000-ish, right? And it was probably before that, because they don't always do the same conferences every year. Some of them may take a break from year to year. They do it every other year, maybe every 3 years, whatever it is. In any case, it's been around a while. My point is, this is not a new topic when it comes to meteorology. And realistically, most of us at some point have been getting automated weather forecast in our lives, right? So you may not think of it that way, but if you ever looked at a weather forecast on the web, early days, even on old services like AOL or Prodigy or CompuServe, any of those, there's a good chance some of what you were getting there was automatically generated. Maybe not completely, but had a high level of automated component. But when you think about what I've talked about before, computer models can spit out a forecast, and it was doing those for years upon years. And some people took those raw data, and it was enough of a starting point for them, right? But certainly with the web, and then with the advent of smart devices, particularly smartphones, first PDAs, if you will, you could carry it around and do it in a network environment. But really once smartphones became a mainstay of everyone's lives, most people have been getting automated forecasts of some type probably for a few years now. Now, you may not think about it that way. Maybe you still get something off the radio, or you still watch somebody, a recorded presentation of some kind, whether it's live TV or something on YouTube, wherever it might be, to fill in those gaps, or whether you're watching the Weather Channel or one of the other, weather-oriented, there's, Weather Nation, some others that provide those sort of forecasters in your face. So whether it's your local channel, national, whatever it is. And you may have counted on that, but almost everybody at some point goes to their app. And unless they're reading text produced by one of those same people, there's a good chance you're getting an automated process. Now, you may not have realized that. You may have always felt that the final forecast was delivered by humans, but that's really not the case. And actually, it was summed up. I was listening to a panel on this, and one of the people there was from IBM. And again, IBM and previously had been WSI, who was a large weather company that had been around a long time. Right? And their system had been generating forecasts, on at least a regional or continental and then a global scale for a while. And it allows them to generate forecasts all over. Again, whether it's good or not, that's not the debate at this point. But it allowed somebody to go in and get a forecast that was relatively close to them, that was tuned in theory to them, likely just by a computer, unless the computer did something that was odd, or unless maybe it was a high impact event where some human needed to go in and tweak the values. But still, a lot of times when you pull up a point where you are, or you say, okay, I'm in little town, middle of the wilderness, top of a mountain, wherever it might be, and you're trying to get those forecasts, there's a good chance that it was just an automated thing that went through and applied some rules, some scheme, and it was created. All right. Now, whether you trusted that forecast or not, that's a different story. But again, it was, at least a first level thing that you may have then gone and got tweaked. Now, there's a big difference between that and when we get to weather forecasts that people fully rely on, that people make important decisions on. And currently, I would say, most often in those cases when people are making monetary-based decisions or planning-based decisions, most folks still tend to seek out that human element. Now, that can be, watching a local news channel. That can be, reading a more detailed forecast. Like let's say you're going to go skiing and you may look to somebody to provide more detail. Or if you're on the business side of things, you may have a company you've hired to provide you with a quality forecast. It's like my tropical cyclone forecast. I mean, one of the things we did was try to interpret the data and make some sense out of it. Maybe point some key things to look for, right? Or companies have internal meteorologists, right? That's their role and responsibility. But with all those components, ultimately people making decisions, particularly when, there's some risk or some money involved, they tend still to look to a human component to provide that. Now, the question is when's that going to change? What's the threshold? What's the line, if you will, that we have to get to? Right? And this is, when you think about AI and weather, this is certainly by no means a weather-related topic. I mean, you can look at other things like the facial recognition stuff that we see on phones now, right, to unlock your phone, or autonomous vehicles being another, right? But you may be curious as to what's it going to take to get a good weather forecast from AI, and what are the things that, whether it's me and what I was writing about, or other people that that I listened to talk this week, what are some of the challenges that you run into? And when do I think we'll cross that line, right? Now, for any of these things, and I'll use, like I said, I'll use some of these other things, whether it's the facial recognition or autonomous vehicles maybe, as a way to think about some of these things, because those tend to be in the news a little bit more. But for artificial intelligence to be useful, it needs to have a large sample set to draw upon, right? So we need to have tons of faces, or tons of scenarios that an autonomous car might drive into, or lots of individual weather events of the same type, right? Because if we're going to ask it to predict about thunderstorms, it needs to have a lot of examples to look for, right? Both precursor, during, how it dissipates, those sort of things, to be able to mimic what a forecaster might see, right? Now, again, the model can project those things. The models are getting better. But it's doing it based on, so when a model's doing it, what it's trying to do is it's projecting based on the physics that are inherent to it. Now, we will probably see, and this is, even read a paper about this lately, one of the things we're going to start seeing is prediction of these things happening by AI. So maybe the model resolution isn't strong enough. We need to get down to a granular level, and that's where AI kicks in, because it might not be effective to do it, to try to compute weather at, even at mile apart grid points. At least not for long periods of time. And even these higher resolution models that we run, they tend to run for very short time windows. One, because they start to become less accurate for things we talked about before. But two is just the sheer magnitude. It's like, you can't run it endlessly, and you don't necessarily have the computer power to run that endlessly. So we got to give it a lot of examples, but within those examples, there's got to be good variance. And I'll use when you think about the face thing in general, I'm a pretty easy example. Caucasian, blue eyes. I've got a fair amount of like freckles or moles on my face, so you can see little differences, right? But for that facial recognition software to work, and this gets beyond even fingerprint recognition, that's kind of where it starts, right? And I don't know about you, I still have problems with my fingerprint sensors. It's trying to match up the precision of your fingerprint that's unique to you. Right? That's really doing some analysis and saying, yes, this is definitively Mark that I've got on this thing. It's the same thing with a face. This is definitively Mark's face. And I looked at some of the things that people have done to fake it out or to work with it. And then there's some things you would think that might, trick it up that don't. And it probably just has to do with the fact of what it's really looking at. Is it really looking at your whole face? Probably not. It's looking at very specific things that it knows or has been told, right, that are likely to make you unique. And one of them probably is like eye color. So that's one of the first things it really looks like. For all I know, it may look at hair and it may say, oh, well, that dude don't got any quantity of hair that matters. But again, whatever the criteria are, the key is that there's got to be enough difference between me and the next person, and particularly like somebody that might be related to me that looks similar to me, to make sure that it's me. And the goal is that you don't want to be able to fake it out, right? That's the ideal scenario. Now, the more important, the more distinct those criteria have to be for it to get there. It's got a lot of base examples. We've got enough variance that it can make the distinguishing marks. But the other thing that maybe you don't see as much of in facial recognition, or you don't think about there, is particularly important with weather, is we've got to be able to verify. And this is important when you're teaching AI, and that's kind of where we're at in the weather spaces. We're still training AI to do these things and find these things and to be able to forecast these things. You got to be able to verify what actually happened. Now, that can be tricky with weather because you've either A, got to use measurements that aren't necessarily what we call in situ, or, I didn't have a piece of instrument that measured it precisely, but there was still an estimation, whether it's satellite based or some other method of what actually took place, because you want the machine to be able to say, okay, did I get it right? Did I get it wrong? Because, there's things you can have. You either got it right, either got it wrong, or the other two scenarios are you said it was going to happen and it didn't. Okay, so think about it that way. Don't think about it, that you missed it. You said it was going to happen or it didn't, or it happened and you missed saying it. So false positives, right? And false negative sort of scenario. Now, we get into this of how precise it needs to be, because that's going to be a determination of the type of thing you're trying to forecast. If high precision is needed, then that might be harder to do. If it's just important to know, for instance, did it actually rain versus not rain, right? The quantity might not be as important. So yeah, it's a little easier to estimate that than if you need a precise estimation at 1 mile intervals of precisely how much precipitation fell in these scenarios, right? So that gets it to be more tricky. So being able to verify the quality will be able to help train that AI to look for the things properly. And, this is where we get back to it. If you're just talking about rain, well, you might have a lot of examples of that. But if you're talking about rapid intensification of tropical cyclones, something I mentioned a lot during the course of this past tropical cyclone season, well, you don't have as many examples. Now, this year we had a lot of examples. So those, and we've got all the accompanying satellite imagery and all that in the radar information, whatever it is, we've got all those pieces of information that are going to help in the process of making the AIs better, because we just gave them a bunch of new examples, right? Now, the tricky part with examples in weather space, and I'll stick with tropical cyclones for a minute, because that's a good example of, we want to be able to do a better job with these events, particularly when they rapidly intensify close to land. So we need to, in short time spans, maybe make a big change in who's being evacuated, where's the most danger coming into landfall, etc. And to do that, we've got to have these examples where, 10 years ago, we may not have the right data. So if we're trying to use some of the newer technology, some of the newer satellites, we just don't have the biggest data set yet. But the more examples we have with weather data, because it's a 3D phenomenon and it covers a large geographic space, there's just a sheer volume of data that's going to be involved. And it's always been one of the challenges, right? I mean, we've got challenges now just getting access to some of the data that's out there available, because we're running into bandwidth issues, particularly here in the U.S., that some of the servers that store this data, more and more people are trying to use it, and we're having more and more problems getting access to that data, whereas 10 years ago, very few people would pull upon it. But again, now that we've got all these weather apps and everybody's trying to do things, makes it harder, right? So volume of data, as I mentioned, the high impact events tend to have fewer scenarios, so they might be a little less volume, but we run into the problem there. So a lot of examples, lots of data. Fewer examples, less data, but then you're not going to have as much variance, right? Because what we need is we need to cover the spectrum. You need all the possibilities to be laid out from point A to point B so that you know where the potential is, right? So you might be able to narrow in how the model thinks about it. But if you can't do that because you don't have enough examples, you don't have the distribution to properly do that, right? And then in the end, we still get down to this concept of trust about when are you going to trust that weather forecast? How far along does it need to be? And I could say the same thing about autonomous cars. We've been watching it for a while now. There's been a lot of thought and effort put into it. And when are you going to trust it? When are you going to feel comfortable that it's had enough examples of how not to hit a pedestrian in snow in low visibility conditions, right? What's it going to take for you to feel comfortable in that? Now, the argument might be, well, it doesn't happen that often where I'm at in Florida, but that doesn't matter. Okay, good for you. So you don't have to worry about that. But for a country like Norway or, parts of Canada or even parts of the U.S. where, snow in the wintertime is a real thing and even poor, particularly in the wintertime with daylight hours being more constrained, what's going to be critical? So it's making sure they've got enough examples of what to look for and how it looks so that they can make the right decisions. Because the flip side of that is we never want someone to get hit by a car. Now, it happens with humans all the time, but autonomous vehicles, we're going to give them even less wiggle room, right? We're going to expect them to be perfect. But the other thing we don't want to have happen is, and I've seen this in my car that I have right now. I've got a Subaru Outback that I bought in the last few years, and it has these things where it tells you that you're in your lane or not in your lane, and it does assist. But it even tells you in the manual, like if you have certain turns or certain lighting conditions, that I've watched it before. I've watched it not too long ago, actually within the last couple of weeks, where I was out on the road. It's time of year when the sun level is lower here, so I get a different profile of what the car sees, if you will, even though it's not looking necessarily in the sun with my naked eyes, sort of thing. But it threw on the brakes to avoid a collision. There was nothing there. It was absolutely nothing there. And all I can think of is that there was some light reflection because of the lower elevation of the sun that came through maybe, some in between some buildings or trees or something that triggered it, right? And I've had that happen a few times. And that's the flip side, right? You don't want an autonomous car that's going to stop every 5 feet because it thinks there's something when there's not. And it's the same thing with weather. I mean, if it keeps telling you there's going to be thunderstorm every day, and there's not, well, you're not going to believe or trust in that, right? So weather has tended to be a little slower on the uptake because traditionally people are trusting that human element, I think, still, particularly with major decisions, because it can be very impactful, or whether it comes to risk and monetary, right? And I think autonomous cars isn't, but I gave you that example because we're the same place there, right? We want to see those kinks worked out. And I think cars are probably further along, probably because there's a little more money in it, probably, right? Because one way to think, I brought up those disasters in the beginning. We might have been able to avoid some of that damage if people had been able to get out of the way. But some of it's going to happen no matter what. If a hurricane's going to blow through a region and there's infrastructure there, well, some of that damage is going to take place no matter what happens. So it's not like there's still not going to be billion-dollar losses potentially. It's going to be influencing the part that you can do something about. Whereas autonomous vehicles, there's probably money in every day. How efficient they get from point A to point B, driving the right times of day, avoiding accidents, et cetera, et cetera. And it impacts everybody, that are trying to go from point A to point B. So really, where is this line, right? We've talked about the fact that we all use them already, okay? But where are you right now? Do you still need someone to tell you the forecast before you really trust it? Or do you really believe in your phone? Where is it? Where is that line for you? When will we cross it? I can tell you this is a very hot topic in the weather space. It's not a new topic, but it's very big right now to the point, and I found this interesting this week. One of the first sessions I sat in on, the National Science Foundation has disfunded on the order of, I think, like $100 million. I don't remember what the amount of money was in this specific hub, if you will. But they started one that's the AI Institute for Research on Trustworthy AI in Weather, Climate, and Coastal Oceanography. All right, so this whole new thing got funded. And I heard the people, some of the main people involved in it talk this week. It was one of the first groups that did a talk. And actually the chair for the AI conference in general, I think, is one of the principal investigators in this group, or one of the leaders of this group. Again, link in the show notes if you really want to geek out about where AI and weather is. It talks about that. And I saw some great presentations about that are still, though, very much in research phase. And that's one of the challenges people always have to remember is I can go to these conferences and I can see some really great things, but I always have to temper myself and go, yeah, but how many years away is that from really being introduced into what we're doing for you who might use a weather forecast, right? But do let me know. I am curious if you today trust what is essentially an automated forecast, and you can probably figure out if it's automated. And what is the line at which you still go, okay, I want to get a human's perspective on that forecast? But don't forget, your robot's doing a lot of things. Cut your robot some slack. He's doing a lot of the work. The computers, the robots are doing a lot of work. And yeah, it could be a virtual robot when I say it's not like it has to be a physical being out there doing his thing. Before you know it, with all the technology we have, that robot might read you the forecast and you might think it's a human and you might believe it. I don't know. We're probably not that far from that, right? But let me know your thoughts. What is about the weather at gmail.com? What is about the weather on Twitter? Or you can hit me at Mark_Jelinek on Twitter as well. But be kind to your weather robot. Make sure he's giving you a good forecast. Because he may not realize, but I know you and I do, that there's much more weather than the weather itself.